Okay, so on number 4, we've got y equals negative. Y equals negative. And then do you guys remember how to get the absolute value up? How do we type it? Yeah, the vertical lines for absolute value. How do we get those up on the screen? Shift, and then the key above the enter. Okay, absolute value x plus 1 plus 5. Okay, and then if you guys remember, it's easiest to graph these if you know what the vertex is, and you can get the vertex right from the equation. So can anyone see what the vertex is? What's the vertex? Negative 1, 5. Okay, so negative 1, positive 5. Negative 1, positive 5. So I'm going to go left 1, up 5. There's my vertex. Okay, so let me go ahead and graph that. Now, to be able to get all the points that I need to get, because I want to get a few points to the left of that, a few points to the right of that, I'm going to go up here on Desmos and click the gear. And then I'm going to go over here and click on the table. So click on the gear, then click on the table. And what I want to see is I want to be able to see the point negative 1, 5, which is right here for the vertex. And then I want to be able to see a few points to the left of that. Right now I can only see 1 point to the left of that, and I want to be able to see more than 1. So I'm going to go ahead and I'm going to take my cursor and I'm going to put it right by the negative 2, and I'm going to press enter a couple times. And then I'm going to fill in some more points in the graph. So I'm going to type negative 2. I'm going to type negative 3. Oops, negative 3. I'm going to type negative 4. And now I can see the vertex, and I can see some more points over here. So negative 1, 5, negative 2, 4, negative 3, 3. And now I can graph those. So negative 1, 5, negative 2, 4. Negative 3, 3. And then I can graph points on the right. Those were always there. They were a little bit easier to see anyway. So 0, 4, 1, 3. 0, 4, 1, 3. All right. So once you're able to do this on Desmos, I want you to hold up your Chromebook screen so I can see it. So go ahead and flip it around. Show me that you were able to pull up those points. Marvelous. Perfect. Thank you. I want to see all the points that I got. Daniel, I want to see all the points that I got. Perfect. Could you have more of the points, the ones that I got, the negative ones? I want to see that everyone can get all the extra points. That's something that we know how to do. Mm-hmm. Okay. Perfect. And I want to see more of the negative points. Yeah. There we go. Perfect. Yep. Perfect. Yep. All right, so we've got this graphed. And for this equation, what transformations do we have? We have a negative in the front. What transformation is a negative in the front? Reflect over the x-axis. What about the plus 1? What transformation is that? Left 1, okay. What transformation is plus 5 on the end? Up 5. Okay, let's do number 5. So transformation, we have a 2 in the front. What transformation is that? Vertical stretch. Okay, we have a vertical stretch. If you want to be really specific, you can say it's a vertical stretch of 2. The minus 3, what transformation is the minus 3? Right 3. And then the 1 on the end is an up 1. Okay? What is the vertex? +3, +1. Okay? If the 2 is positive right here, and you could have graphed this on Desmos to see it, but if the 2 is positive right there, does this V-shaped graph go up or does this V-shaped graph go down? It goes up. So the V-shaped graph looks like this. Okay? We know that the vertex down here is 3, 1. So if we're doing the range, and the range is based on y values, so that the range goes from down to up, if the down part is down here and the up part is right there, for down to up, what number should I put for down here? 1. I should put 1 because range uses the y values. So I'm going to put 1 for the down part, and then what number do I put for the up part? Infinity, because it's arrows that go up forever. All right, infinity always gets a parenthesis. For the down part, I can put my finger on it. So should I put a parenthesis or a bracket? Bracket, because I can put my finger on it. Okay? Based on this picture, is there a maximum or a minimum? There's a minimum. It's a valley. It is not a mountaintop. It's a valley. It is not a mountaintop. Okay. How do we feel about that stuff? Kind of making sense? We got to keep putting it on warm-ups? Yeah? Okay. All right, let's put that away. Let's get out a sheet of notebook paper to take some notes. A sheet of notebook paper to take some notes. I know you guys have been loving what we've been doing so far, and you are like, wow, it's been a really long time since we've had a quiz. So tomorrow we have a quiz review warm-up, and then a quiz. Not a big one, just kind of a little quizzy quiz. Okay? Just want you to feel ready for it. Yes? Okay. We'll make sure we get that done. Okay. Solving absolute value equations. All right, so one thing that we haven't talked about yet that we are going to learn the specific of today is what absolute value actually means. So up until today, we said that what the absolute value does is it just takes whatever is inside the absolute value symbol and it makes it positive. And the reason that it makes it positive is because the actual definition of an absolute value is it is the distance from whatever is inside. It is the distance of that number to 0. So if I have an x right here, then I'm saying that this absolute value, this is saying the distance from x to 0. The distance from x to 0. That's what absolute value means. So if you were to go for like a walk or something, even if you went out of your house or apartment or whatever and went to the left, you would not say, oh, I went to the left, so I went -1 mile. Nobody would say that. They'd say, I walked a mile. You wouldn't say, I went down the stairs, so I went -3 feet. Whenever we talk about distances, we always say that that distance is positive. It doesn't matter if we went left or right. It doesn't matter if we went up or down. We always say distances are positive. Does that make sense? It is silly to say that a distance is negative. That is why absolute value is always written as a positive, because you're always describing how far away that number is from 0. So if you take the absolute value of -3, you're saying how far away from 0 is -3. It's a distance of 3 numbers away from 0. What's the absolute value of 5? You're saying how far away from 0 is the number 5. It's a distance of 5 numbers away from 0. How far away from 0 is the number -7? It is a distance of 7 numbers away from 0. So that is why we always just say, oh, absolute value is about taking a number and making it positive because it has to do with distance. Does that make sense? Okay. In most cases, that didn't matter, but today it does. All right, so we're going to go ahead and do a few examples so you can see what I mean. For the first example, we're going to keep it pretty easy. We're going to say the absolute value of n equals 9. So we're going to say, what could the number be if the distance away from 0 was 9? What could the number be if its distance away from 0 was 9? So the number itself could be -9, or it could be what else? +9. So if the number was +9, it would be a distance away from 0 of 9 spaces. Or if the number was -9, it could be a distance away from 0 of 9 spaces. We would always have two possible solutions here. +9, -9. Both of those would work. Does that make sense? Okay, let's try another one. Let's say that we had 2 times a number equals a distance of 8. 2 times a number equals a distance of 8. So what number could you have where 2 times that number would be a distance of 8 away from 0? 4. If your number was 4, then 2 times 4 is a distance of 8 spaces away from 0. What else could your number be? -4. 2 times -4 is a distance of 8 spaces away from 0. So +4, -4. Okay, let's see. What if I said the absolute value of n equals -7? What if I said, what if I'm thinking of a number, the distance of that number from 0 is -7? Wait, think about it again. The distance of a number from 0 is -7. The distance is -7. The distance is -7. The distance is negative. What would you say? No. Think about it again. The distance is -7. I walked -7 miles today. You're crazy, right? You would say that's silly. You don't walk a negative distance. So here we would say no solution. You can't go a negative distance. That's silly. See the difference in those problems? So if your distance is a reasonable number, you solve it. If your distance is unreasonable, if they're trying to tell you that a distance is negative, you stop the problem. You don't even solve it. You say, I'm not doing that, that's silly. No such thing as a negative distance. Okay, no solution. And that's because no such thing as a negative distance. No such thing as a negative distance. Okay, let's try another one. All right, this one might hurt your brain a little bit. So we're going to say a number, I'll use n, a number plus 3 is a distance of 8. A number plus 3 is a distance of 8. So what would the number be? 5. Okay, for sure the number could be 5. Now, let's think of another number plus 3 where the distance could be 8. Another number plus 3, -11. Can everyone see how -11 would work? So if we did -11 plus 3, what's negative 11 plus 3? Negative 8. And then that would be a distance of 8 spaces away from 0. Okay? So n could equal 5. It could also equal negative 11. So whenever we go about solving absolute value equations, we always have to think about, okay, there's the regular version, there's like the positive version that all of us would find easily. We also have to think about what could have made this the opposite sign. What could have made the inside equal negative 8? Because you could have been like you went left. Like you went the opposite direction, like you went down the stairs instead of up the stairs, or you walked out of your apartment and you went left instead of right. Does that make sense? Okay, so now we're going to do some problems that use a little bit more brain power, and instead of doing the math in our heads or kind of doing like a guess and check method, now we're actually going to show our work, okay? So I'm going to say for this one, we're going to do n plus 6 equals 15, and I'm going to show you guys how we would actually show our work for this so we don't have to use our brains quite so much. So with this, we would say, okay, there's going to be 2 answers. We could have that n plus 6 equaled positive 15, and so the distance was 15. Or we're going to have n plus 6 equaled negative 15, and so the distance was 15 away from 0. We have those 2 options. That the inside equaled positive 15, so it had a distance of 15, or that the inside equaled negative 15, so it was a distance of 15. Okay? So if we're going to solve for n, we're going to go ahead and we're just going to minus 6 from the left side, and we're going to minus 6 from the right side. And so n equals 9. Okay, so one of the numbers could have been 9. If our number is 9, then 9 plus 6 is a distance of 15 away from 0. That makes sense? Okay, over here I'm going to minus 6 and minus 6. N equals negative 21. If our number was negative 21, then negative 21 plus 6 is negative 15. Negative 15 is a distance of 15 spaces away from 0. Okay? How do your brains feel about that? Make sense? So the thing that we have to remember today when we solve absolute value equations is that there are always 2 equations. Oops. 2 equations. Okay, I'm going to hand out your worksheet. We're going to try some of the simple problems, and then we're going to come back to our notes and try some more difficult ones after we do the simple ones. 0 is 10 and negative 10. Okay. Now with number 3, we could show a little bit more work, so we can write our 2 equations. So I'm going to say the inside could equal positive 17, and that's how they said it had a distance of 17. Or the inside could equal negative 17, and that's how they said it had a distance of 17. Okay, so what should I do? Wait, it's already subtracted. Add the 9, okay. 17 plus 9, 26, okay. And then over here, negative 17 plus 9. What is it? Negative 8? Okay. So if we did 26 minus 9, we get 17, which is a distance of 17 away from 0. If we do negative 8 minus 9, we get negative 17, which is a distance of 17 away from 0. Okay, so those numbers make sense. Over here, this one doesn't have the absolute value sign alone. We are used to seeing it alone. So let's go ahead and take this 1 and subtract it over to the other side. So I'm going to take the 1, I'm just going to move it over. N divided by 10 equals negative 1. Anybody notice anything about this one? Wait, do you notice it? No solution, because why? It equals a negative. Where we see that? So this one is trying to say there's a number that when you divide it by 10 has a distance of negative 1 from 0. Can you have a distance of negative 1 from 0? Nope. No solution. Okay, I want you guys to try number 2 and number 4. Okay, let's try a couple more. So go back to your notes. All right, this time we're going to do let's do 6 plus 2x minus 1 equals 35. So this adds one extra step before we can break the problem into two equations. It just adds one extra step. So we can only break the problem into two equations when we have the absolute value alone on one side and the number, which is the distance, on the other side. So we don't have a distance yet because the 6 is ruining it for us. Okay? So how could I get rid of this 6 over here? I could subtract it. It's a positive 6 just sitting there. I could subtract it over to the other side. So I'm going to go ahead and subtract the 6, subtract the 6. So now I'm going to say the absolute value of 2x minus 1 equals 29. And since this is an absolute value, it means distance. So the distance of whatever this number is away from 0 is a distance of 29. Now I can go ahead and break this up into my two equations. Okay? So I can say whatever that number was, this number could have had a distance, or it could have equaled 29, so it had a distance of 29, or this number could have equaled negative 29, and so it had a distance of 29. So whatever this number is, could have equaled 29, so it had a distance of 29, or it could have equaled negative 29, so it had a distance of 29. Could have gone either way. Okay? So the important thing was we subtracted the 6 over before we did our two sets of equations. Okay. Now, as we solve our two sets of equations, what's the first step going to be? We have the x right here. We want to add the 1 because we want to leave the x alone. So I'm going to add the 1 over to the other side. And I can do that on both of my equations. So 2x equals 30. 2 2x equals you're close. Negative 28. Negative 28. And then how do we get the x alone? Divide. So 2 times x, anytime they're written right next to each other, it means they're multiplied, so we're going to undo that by dividing. So I have 2 values for x. What are my values for x? 15 and negative 14. Good. Okay, how do we feel? Kind of okay. So we added one more step in there. We put another number in there. Okay, let's do another one like this. All right, so here's the problem. We're going to do negative 8 plus the absolute value of 3x plus 5 equals $41. I tried to make it equal a whole number, you guys, but I might have done my mental math wrong. So if it equals a fraction, don't be upset. Okay. So first step is what? We got to get rid of that negative 8. We got to add the 8. We got to add the 8. Okay, so we have 3x plus 5 is 49. And at this point, we can say whatever this distance is, it's a distance of 49 spaces away from 0. Okay, so what should I do now? Before subtracting the 5. Might need to look back at your other problems. 2 equations. I have to write it as 2 equations. And then once I write it as 2 equations, subtracting 5 is perfect. So 3x plus 5 could have equaled positive 49, and that's what gave it a distance of 49. Or 3x plus 5 could have equaled negative 49, and that's what gave it a distance of 49. Okay. So now we're going to go ahead and do what Destiny said, and we're going to subtract 5. And subtracting 5 is going to keep our x all alone on the left side. So 3x equals 44. And 3x equals negative 54. Okay. And then what do I do next? Divide it by 3. So we do get a fraction for that one. Over here, divide by 3, and I think we get a whole number over here. So 44 thirds I'm going to leave as 44 thirds. Negative 54 over 3, has anyone divided that? Negative 18? Perfect. Okay. All right, we're going to try one more that has just one extra step to it. And then I'm going to let you guys try a few more problems. So this one is going to be 5 times 8a minus 5 equals 105. So our goal is to get the absolute value alone. The 5 in the front is ruining that. What is the 5 in the front doing? It's not being added. What is it doing? If it's right next to it, what is it doing? It's being multiplied. So how do we undo being multiplied? We divide it. So I'm going to divide by 5 on the left side, and I'm going to divide by 5 on the right side. So now I can say I have my absolute value, and whatever's inside of that has a distance of what? 21. 105 divided by 5 is a distance of 21. So this is going to be a distance of 21 away from 0. Okay, so what should I do next to show my distance of 21? It's not a divide step, it's not an add or subtract step. I do 2 equations. I show that there's 2 different ways I could get a distance of 21. I could have 8a minus 5 equaled 21. That would give me a distance of 21. I could have 8a minus 5 equals negative 21. That would also give me a distance of 21. Okay, so what should I do now? I'm going to add the 5. Going to add the 5. And it looks like we're going to get fractions for both of these answers. So it's okay if you're working ahead getting fractions. Okay, so 21 plus 5 is 26. So we have 8a equals 26. And then over here, we have 8a. And what's negative 21 plus 5? You're close. Negative 16. Good. Ooh, not 2 fractions, just 1 fraction. Okay, so over here, we're going to solve for a. What are we going to do? We're going to divide by 8. Okay. And now when I do fractions, I like to keep fractions because they're actually more accurate. So 26 over 8, do you guys see how those are both even numbers? That means we can reduce the fraction. So you could do it yourself by just saying 26 divided by 2 is 13. 8 divided by 2 is 4. And then you could write that as 13 fourths. Or if you don't want to do it yourself, we can type the fraction into the calculator and let the calculator reduce it for us. So does anyone remember how to make their calculators type a fraction? Starts with the green button. Yep, alpha y equals, good. Alpha y equals, we press enter. And if you type 26 over 8 and then press enter, it will reduce it for you. So 13 over 4. It just reduced it for us. So 13 over 4. So A equals 26 over 8, which is 13 over 4. And then over here, if we divide by 8, what do we get? We get -2. Okay. So on your worksheet, try number 6, 7, and 8. 6, 7, and 8.